Our today's discussion topics is glycolysis. This is our fourth class on our topics metabolism. Now, what is glycolysis? The oxidation of glucose to pyruvate and lactate is called glycolysis. It is also called Embden-Meyerhof pathway. Glycolysis is an anaerobic phase of carbohydrate metabolism. All the enzymes of glycolysis are found in the extra mitochondrial soluble fraction of the cell. Now, the reaction of glycolysis. The reaction involved in glycolysis are first glucose to glucose 6-phosphate. This reaction is catalyzed by enzyme hexokinase. ATP, here the ATP acts as phosphate donor. The presence of magnesium ion is necessary in this step. The reaction occurs mainly in the liver and muscle. This reaction is also irreversible. Now, the second step, glucose 6-phosphate to fructose 6-phosphate. In this step, this reaction is catalyzed by the enzyme phosphohexose isomerase, and the next step, this produces fructose 6-phosphate to fructose 1,6-biphosphate. In this step, this reaction catalyzed by enzyme phosphofructokinase, and here ATP acts as a phosphate donor and the ATP is converted in ADP. In the fourth step, fructose 1,6-biphosphate, this reaction is catalyzed by enzyme aldolase. Both glyceraldehyde 3-phosphate and dihydroxyacetone phosphate are produced. Then glyceraldehyde 3-phosphate to 1,3-biphosphate glycerate. This step is catalyzed by enzyme glyceraldehyde 3-phosphate dehydrogenase. This reaction requires the coenzyme NAD. 6 molecules of ATP are formed as a result of this reaction. NADH formed in this reaction, which is oxidized in electron transport chain to produce 3 molecules of ATP. For 2 molecules of 1,3-diphosphoglycerate, a total of 6 molecules of ATP will produce in this step. Now, 1,3-diphosphoglycerate to 3-phosphoglycerate. In this step, phosphoglycerate kinase is used as an enzyme, and in this step, ATP is produced. And the next step, 3-phosphoglycerate to 2-phosphoglycerate. In this step, phosphoglyceromutase is used as a enzyme. This phosphoglycerate mutase catalyze 3-phosphoglycerate to 2-phosphoglycerate, and this is also reversible reaction. And in the next step, 2-phosphoglycerate converts phosphoenol pyruvate, and here enolase acts as a enzyme. And in the next step, phosphoenol pyruvate is converted to pyruvate, and in this step pyruvate kinase is used as a enzyme, and on that step pyruvate is converted to lactate in presence of lactate dehydrogenase, and from pyruvate its aerobic metabolism to produce CO2. This is a glycolysis, and in this step pyruvate is produced from metabolism of glucose. Thank you.